Alright, so what I'm going to do is I'm going to show you how to find the vertical and the horizontal asymptotes of a given function. So the first thing we want to do is when we're finding our vertical asymptote, our vertical asymptote is going to tell us pretty much what values of our function are not going to cross on the x-axis. So what it's very similar to is actually finding the domain. And if you remember, when you have a rational function, to find the domain, you determine what values make it 0 on the bottom. And whatever values make it 0 are not going to be a part of your domain. And that's the same thing with the vertical asymptote, because if you think of a vertical asymptote, it's going to be a number, it's a vertical line that it's a value of x that your graph does not have or is not defined for. So to determine this, I'm going to set each one of my values. So when I want to find my vertical asymptote, what I'm going to do is I'm going to set the bottom equal to 0 for each problem. And this is just very similar to like finding the domain. And the reason why is, remember, whatever values make it 0, that's not part of my domain. And since it's not part of my domain, it's not an x value in my function, or my function is not defined for that value. Therefore, it's called what we call an asymptote. And meaning an asymptote is when you look at a graph, the graph is never going to have a value at that point. And we'll get into it when we talk about graphing. You guys will see what I'm talking about. So here, I'm just going to add 3. X squared equals 3. Square root. X equals plus or minus 3. I'm sorry, square root of 3.
Yeah.
Right? So therefore, my vertical asymptote for this problem, that means the x values are x equals plus or minus the square root of 3. So we'll get into graphing later. Here, to find the vertical asymptotes, I set it equal to 0. And here, since I have a trinomial, I can't do adding to the other side. When I have a trinomial, I'm going to look for factoring. And I see that this can be easily factored into x plus 6 and x plus 1 equals 0. Therefore, my asymptotes are x equals negative 6 and x equals negative 1. I'll just try to make it a little bit quicker. Remember, just set each one of those equally to 0, and then you solve, right? Okay. Here, this one's very easy. I already know that x is 0 as my vertical asymptote. So the next one is we need to look at our horizontal. It's very hard to write with a pen like this, or at least upside down. So when you want to find your horizontal asymptote, what we need to do is we're going to look at, there's two things. We need to look at our leading coefficient. So we need to compare our leading coefficients and degrees. So when you guys look at each one of these problems, we need to look at the leading coefficient and the degree of our leading term. So here, of each polynomial. So of the top and on the bottom. So you compare leading coefficient and degrees for your polynomial up top and polynomial at the bottom. Here we have a polynomial, but it's a constant polynomial. Now, a lot of you might say, well, there's no x right there, right? Well, I can put x to the 0 power, because any number anything raised to the 0 power equals 1, right? 1 times 3 would be 3. So then the next thing I want to do is I want to compare my degrees, all right? And when my degree up top is less than the bottom, so when 0 is less than 2, the top is less than the bottom, right, of your degrees, my horizontal asymptote is going to be y equals 0. And I'm saying y because this is your y-axis and that's your x-axis. So my y value is going to equal 0. All right? 0. So whenever your top degree is less than your bottom degree, your leading coefficient, how am I doing that over there? Y is equal to 0. Okay? Next one. What?
Is that because you divided 0 by 2?
No, it's just whenever. It doesn't matter if that was 1 and that was 3.
Okay.
Whenever you have a top is smaller than your bottom degree, it's always just y equals 0.
Okay.
Always. So it doesn't matter if it's 5 and 50.
Okay.
It's 0, it's less than, so y equals 0. Now, when you have that equal, okay, what you do is you take the number in front, which there's no number in front of here, right? So we write 1. You take the number in front and you divide them. So whenever they're equal, so when you say like the top is equal to the bottom, what we do is we take our coefficients and we divide them. So we say y equals 1 over 1, which is 1 in this case. Does that make sense? So whenever they're equal, so if this was like a 3/4, then it'd be 3/4, right? So just always divide the coefficients. And then now when we can put a 1 there. Whenever we have the top is larger than the bottom, so you can say the top is larger than the bottom, there is no horizontal asymptote. No horizontal asymptote. And that means there's going to be a slant, which we'll show in another video. But if you guys can just remember, whenever the top degree is smaller than the bottom degree of your leading term, then your horizontal asymptote y equals 0. When they're equal, you take the two coefficients and you divide them. And here, 1 divided by 1 is 1. And here, whenever it's larger than the bottom, there's no horizontal asymptotes. And that's how you find the horizontal and the vertical asymptotes.
So basically all you need to find out horizontal is the coefficient.